Hi students, see today we are going to discuss about the very important lesson, that is carbon and its compound. The very important things is, see many of that we are using everyday food, clothes, that building materials, many things they are contains carbon. In paper, whatever it is, many of the things are carbon containing compound. So this lesson we are going to discuss about the carbon and its compounds. Then the bonding of the carbon compounds, that is covalent bond. Then allotropes of carbon, that graphite, fullerene, diamond, that's also we are going to discuss in this video. Now bonding in carbon, that is covalent bond. See, already we seen that many of the compounds like metals and non-metal, already we studied, that is the ionic properties, that is the ionic compound. The ionic compound have the high melting and the boiling point. They conduct electricity and heat also. Usually they are molten state or in the solution state, usually conduct the electricity for ionic compound. In this compound and carbon compounds, many of these properties are non-ionic in nature. So usually they are poor in conduct electricity. See, they have a few examples are written here. The acetic acid. The acetic acid having the melting point is 290 Kelvin and the boiling point is 391 Kelvin. Then the chloroform melting point is 209 Kelvin and the boiling point is 334 Kelvin. And the alcohol, this is ethanol, the melting point is 156 Kelvin and the boiling point is 351 Kelvin. Then the methane is melting point is 90 Kelvin and the boiling point is 111 Kelvin. Usually the most of the compounds, that is the carbon compounds, are poor conductor of electricity. Already we know that. See, here the melting and the boiling points are given. Here we can conclude that they have the forces of attraction. In ionic compound, they have the electrostatic forces. But here that the forces of attractions are very weak. In ionic compound, usually the forces of attraction is strong. Here the compounds are largely the non-conductor, usually the non-conductor of electricity. Now that's mean we can conclude that bonding in this compound do not give rise to the any ions. That is why they are non-conducting in the electricity. See, here the carbon, already we learned that is a combining capacity of the various elements and how it depends on the number of the valence electron. Now, just write the electronic configuration of the carbon. Here, the carbon atomic number is what? 6, and the electronic configuration will be 2 and 4, 2, 2, 4. So, this is the electronic configuration. Here, the K shell having 2 and the L shell having 4 electrons. Suppose here we know that the reactivity of the elements explained as their tendency to attain the completely filled outer shell. Here, usually the outer shell, the first cell is 2, the combining capacity, maximum capacity is 2, remaining the next cell onwards, the maximum electron capacity is 8, that is octet, we know that. See, here the completely filled outer shell that attain the noble gas configuration, here only 4. Suppose the elements forming the ionic compounds that achieve by either gaining or losing electrons from the outermost shell. So, in the case of the carbon, it has 4 valence electron. Here, the 4 valence electron. So, in the outermost shell, suppose it lose or gain. In case it could gain 4 electron, forming the C4 anion. But it would be difficult for the nucleus with 6 proton to hold on the 10 electrons. Okay, that is 4 extra electrons are there. Then, suppose in case of loss of 4 electron, forming C4 plus cation, but it would require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 protons in its nucleus, holding on to the just 2 electrons. So, that's why the carbon overcome this problem by sharing its valence electron with other atoms of carbon or with atoms of the other elements. See, not just a carbon, but many other elements like sharing of electrons in this manner only. So, sharing of electrons belongs to the outer shell of the both atoms, and let both atoms attaining the noble gas configuration. So, before going to this carbon, just already we seen the formation of hydrogen, formation of oxygen, formation of nitrogen also we will discuss here. See, here the hydrogen is the simplest element. The hydrogen, the atomic number is what? 1. The hydrogen has 1 electron in K shell and it requires 1 more electron to fill the K shell. So, 2 hydrogen atoms are share their electrons from the molecules of hydrogen, that is H2. That this allows each hydrogen atom to attain electronic, that is electronic configuration of the nearest noble gas configuration. Here the nearest noble gas configuration was, that is helium. Helium is a noble gas element, so the atomic number is 2. So, here that hydrogen formed like this H2 molecule. Only the hydrogen exists in H2 form in a single state. Suppose the shared pair of electron is said to constitute a single bond between the 2 hydrogen atoms. Usually, the single bond, the 2 electrons contain, we can write it, this is a single line, is called a bond. It is a single bond. This single bond contains 2 electrons. The single bond contains 2 electrons. We can write it simply, we can denote it just H. Or H2 means the molecules look like only. Okay, we can write H2, but the H2 molecule looks like, because the sharing of electron from one hydrogen atom, another electron from another hydrogen atom to exist H2 molecule. Hydrogen never exists in the H form. Okay. Then similarly in chlorine atom, bromine atom, like this the halogen also. For example, next is the oxygen. What is the oxygen atomic number is 6. The oxygen atomic number is 6 and the electronic configuration will be oxygen electronic atomic number is 6. So, the electronic configuration is oxygen atomic number is 8 and the electronic configuration is 2, 6. Here the valence electron in K cell 2 electron and the L cell having 6 electron. Here the L cell is the outer cell. So, just write here oxygen molecule. So 6 valence electron you can write star, or you can write in the just dot. You can use it either star or dot. Then here only 6 electrons are there. Now oxygen is a diatomic molecule. So next one more oxygen atom I am going to write here. So just this also, this oxygen atom also 6 valence electron. Now here this formation of the O2 molecule, so combining of these two, what happens? So just I am writing here like this. So this is one atom and this overlap with another one oxygen. What happened here? Totally 4 electrons. We can write that 4 electrons, 2 electrons we can write a single bond, and one more 2 electrons are possible, so that another one line. So the oxygen between this, the remaining is called unshared electron pair or the lone pair of electron. That means they are electron is rich compound. So the oxygen having the double bond. This hydrogen, already we seen that the hydrogen is H2 molecule, we know that H. So this having single bond, the oxygen having double bond. In the case of nitrogen, suppose if we take nitrogen, the nitrogen atomic number is what? 7. Nitrogen atomic number 7. So the electronic configuration is 2, 5. Here the valence electron is what? K shell is 2 and the L cell having the 5. So that is the outer cell. Now write the nitrogen atom. Nitrogen also exists in the N2 diatomic molecule. So nitrogen, the valence cell you can write it 3 and 2. So this is a diatomic molecule. So one more nitrogen atom also I am writing here. Here also they have 5 valence electron. Now the combining capacity of this nitrogen atom is, so just I am writing like the dot like this. This overlapping like this and this one like this. The remaining is called lone pair of electron, that we can write like this, or we can write in the upper part of the nitrogen atom. So here how many electrons are present? 6 electrons. So we can write it in this nitrogen atom 1 electron, so 2 electron one bond, the next 2 electron another one bond, then the next 2 electron is another one bond, then nitrogen. The remaining is what? The unshared electron pair. This is called also called lone pair of electron. So nitrogen usually exists, that is N triple bond N. We can write nitrogen is N triple bond N. The maximum possibility is, that is single bond is usually there, double bond is one possible, and the triple bond is possible. That is the maximum possibility. Single bond, double bond and the triple bond. So this is the combining capacity of the simple elements. Next is the allotropes of carbon. Many of the in all elements in a periodic table, all elements having the allotrope, carbon also having the allotropes form. The first is graphite, diamond and the fullerene. Usually the element carbon occurs in a different form in nature with widely varying physical properties. Here both diamond and the graphite are formed by carbon atom. The difference lies in the manner in which the carbon atoms are bonded to one another. In diamond, each carbon atom is bonded to 4 other carbon atoms forming a rigid 3D structure, that is 3-dimensional structure. In graphite, in the case of graphite, each carbon atom is bonded to 3 other carbon atoms in the same plane, giving a hexagonal array. Then one of this bond is double bond, and thus the valency of carbon is satisfied. So then graphite structure is formed by the hexagonal arrays being placed in a layer one above the other. You can see the structure. Then these two different structures result in diamond and graphite having very different physical property, even though their chemical properties are the same. A diamond is the hardest substance, you know that, while the graphite is the smooth and slippery. The graphite is also a very good conductor of electricity, unlike the other non-metals that you studied in the previous classes. Then the diamond can be synthesized by subjecting a pure carbon to very high pressure and the temperature. So these synthetic diamonds are small but are otherwise indistinguishable from the natural diamond. Next structure is fullerenes. The fullerenes form another class of the carbon allotropes. So the first one to be the identified, the carbon 60, that is C60 form, which has the carbon atoms arranged in the shape of the football. So since it looked like a geodesic design, that is the US architect Buckminster Fuller, that is why the molecule was named as fullerene. Hi students, see, today we were seeing the bonding of that carbon compound, that is the covalent bond. The covalent bond already we seen that formations of the hydrogen molecule, then formations of the oxygen, then formation of the nitrogen, that is single bond, double bond and triple bond we were seen. Then the allotropes of carbon also we were discussed, that is you were seen that structure of the allotrope, that is diamond, fullerene and the graphite structure also you were seen. So just read the importance of the carbon compounds.